So, hello people of vvvv. This is MicroD here, and today's workshop will be held by Motzi, as you can see on the screen now.
Am I online already? I'm not watching the stream, but yeah, if you can see me, hello from Vienna. First of all, well, a big thank you to MicroD for hosting these kinds of workshops. That's really a great thing to have. Today we'll give you a soft start into the topic of machine learning, and we're not going to be using any of the machine learning pack today that I created last year for the node. But we'll use some examples from a different world, from the Kinect world, because Kinect has some nice features actually that are not known by many. And our great contributor Vux, thank you Vux for this. He made some nice notes for using these features. Actually, the Kinect has some nice feature that's called gesture recognition. Well, a gesture, that's something that you can use with the Kinect. You know, the Kinect makes body tracking that allows you to track your body as a skeleton. And with the body, you can do gestures like certain movements, like a punch gesture or maybe you wave or whatever. And it comes with some machine learning features that allows you to automatically learn these gestures by example. And this is something that we'll explore a little bit later. But first of all, I'll give you a quick demo of what I'm talking about, because this is something that comes in handy a lot of times. You all know the situation that at some point when you do interaction with the Kinect, you want to implement some gestures, and usually you would start off by, just do some comparisons. Maybe is your left hand over the head and is it moving to the right or something like this, if you want to create a swipe gesture or something like this. And I'll give you a quick demo of what actually this gesture recognition that Microsoft provides and is available in vvvv also can do for you. And this little patch here is actually all of the vvvv stuff that we're going for today. And all I did is I did use the Microsoft technology to create some gesture recognition of swipes. That means moving my hand from the left to the right, and use this as a gesture for, well, interacting with your TV like this. As you can see here on the lower end here, I got two toggle switches that are just there if a swipe gesture happens. So the swipe from left to right, I can do it in many ways. I can do it slow, I can do it fast, and the right thing. And actually, it should not trigger too much if I do anything else with my hands. So, well, apparently the threshold that I set here is a little bit too low. Yeah, too high. So it detects small swipes as well. Decrease a little bit more. It should detect small swipes as well as large swipes and stuff like that. So a simple interaction thing. And yeah, the thing is that Microsoft did some very good work here, but it seems to me that they never really finished the stuff they actually implemented here. And for me, it was quite a pain in the beginning to get into it, because it's not very well documented and you have to read through and try a lot of stuff. And I'd like to walk you through today through all of this, just to give you an idea how you can actually use this technology in vvvv. And on the way, I'll explain some of the stuff that actually is related to machine learning. This whole topic that allows you to, well, use the computer and use the computer's capabilities to analyze data in a very thorough way to make sense of the world. It means, like in this example, it tries to make sense of the coordinate data that you get from the Kinect. Yeah? But you can use it for many other things as well. To recognize stuff. Well, that's what machine learning is about. But first things first, I'd like to start off with going through the Kinect Studio and the visual gesture builder that comes with the Kinect SDK. All right. So the workflow for building a gesture like this is the following. at first, you have to collect some data. Machine learning is kind of learning by example. That means that you show the computer several examples of what you wanted to learn. Yeah, and then it will try to figure out actually from the data you gave it what actually makes up this special thing that you're trying to teach him. But it's very similar to what actually humans do when they learn. Yeah? Think of a little child when it grows up and it learns some stuff. It learns to recognize, for instance, letters. How does it recognize letters? Well, a teacher gives him lots of many letters of the type A. There's different fonts and they all look a little bit different, but still there's something that they all have in common. And well, at some point we will figure out what actually makes up a letter A or letter H or letter N or whatever. And that happens here as well. So first, what we have to do is, if we want to do some gesture recognition with the Kinect, we will have to do some recordings. And you probably know, if you have worked with the Kinect, that there's this Kinect Studio, which is an application that allows you to do some recordings. It is actually meant to be some kind of debugging thing, because you can record the movements you make and play them back and use them in your application. So I'll just give you a quick demo. When I open up the Kinect Studio, first you have to connect to the device here. And here in this great view, you see actually some data that the Kinect delivers. So for me, I'll just show you this here. I got my Kinect here over the desktop. You can see the nice infrared lights. And here in this monitor view, you can select actually what you want to see. Just if you're interested, if you go in here in the settings, you can see what kind of stuff is actually there. There's the depth plugin. This is what the Kinect is actually great at. It's good at detecting how far you are away from the device. And this colored image here, or if I turn it to gray, the pixel information in here just tells you how far am I away to the camera compared, for instance, to this wall here in the back. The lighter, the closer, the darker, the further away you are. But what you also get is, what you can see here on me, is the skeleton information. The skeleton information is something where some machine learning program is already processing this depth image. And it tries to figure out, actually, is there a person here in this image? And what it gives you is coordinates of your joints of your bodies. Saying that that's like, here's my elbow, and here is my head. And somehow, with some machine learning program in the background that knows how a human might look like, it can tell you where the limbs of your body are. And this is great because when we get a skeleton of a human, we already got some nice features. Features is something that's some data that is meaningful in a way. Features is a term that's used a lot in machine learning. Having a feature of something is some data that says something about something. Yeah? For instance, if I have a feature I have features of coordinates here that are skeleton coordinates, it's something very useful, because before that we only had this pixel image, and this pixel image is lots of data, but it's very hard to recognize something from this pixel image. But with coordinate information from the body, the skeleton information, we can do much more. Yeah, and the first thing we have to do now is to record some clips of the gestures that we actually want to use later. And if you go here to the record view, actually you get the same view or a different view in 3D, however you like it to be. That's me sitting in front of the desk with some skeleton information. And there is one thing that's not clear in the beginning, because usually when you open up the Kinect Studio and you want to do some recordings, you see here on the left side the stuff that you actually can record, because the Kinect sensor delivers lots of data. It delivers data, for instance, like here's the depth image. It's called Natural User Interface Depth. Here's the infrared image. It's not only a colored image that you get, but also an infrared image. But what is usually not there is this raw infrared 11-bit image. Because what you get from the Kinect is two kinds of infrared image, two kinds of depth images. And the 11-bit image is an image with a higher resolution of the depths, which you usually would like to use. Because, yeah, higher resolution means better quality. And also, this is something that, yeah, especially if you've worked with the Kinect point cloud, is something that you're very happy about. Or if you're using the Kinect for stuff like, well, if you want to clear out the background, if you're using, video keying and stuff like that. But how do you get this one here? Actually, to do this, you have to go into the settings of the Kinect Studio. And down here, there's a button that's called Advanced Stream Display, which you have to activate first. Because if you don't do that, I'll just demonstrate this. Yeah, you will get only a few of these streams that the Kinect actually delivers. So Microsoft, they recommend that if you do recordings for gesture recognition, then you should probably use the higher resolution image, which afterwards will need an additional step because we need to convert these files to the normal images again, which is kind of weird, but they say you should use it because maybe in a future release of the Kinect SDK, there will be better algorithms to calculate how gestures are recognized. And you can only use then the newer, you can only use then the better quality images that you probably have to convert again for the newer technology. Sorry, that was a little bit confusing. The thing is, when you do recordings, yeah, you're building up a database. Yeah, you want to collect some samples of the gestures you want to use, and that means you need to give him a few examples. Like if I wanted to train a swipe gesture like this, yeah, I'm training like maybe 10 or 20 examples of this one gesture. And later on, maybe when there might be a new SDK release, then it will need the original data, the original 11-bit data to be able to use this database that you built, these recordings that you already make, to redo the gestures. Well, so you might want to activate this here. When you activate this here, you see that some other stuff might be blacked out or you cannot use them again, but that doesn't matter for our application here. And yeah, then we'll just do some recordings. Yeah, I just said I want to do this swipe thing. And when talking about gestures, it's always a good idea. I'll just improve the position of my camera here. Yeah, when talking about this swipe thing, it's, people, when they do swipes, they might do it like this, or they might do it like this, and they might do it like this, or like this, whatever. Or maybe even like this, yeah, if they want to go back. You see, there's many different things that you have to keep in mind. If you ever try to create a gesture recognizer for a swipe gesture just manually by comparing positions, yeah. For instance, what you could do is like, take the position of your right hand, and if it moves over the center of your body here, then you can say, hey, maybe this is a gesture that's actually a swipe. Yeah, but some people just make it like this, yeah, and some people just make it like this, and it's hard to tell how people will use this gesture because there's no hard definition and people are not used to this. So what you actually need to do is you have to give it many examples of how is one of these swipe gestures being performed. And I'll be just doing this right now. I'll start off with doing the swipe from right to left, and I'll record some of these samples. So what I'll be doing here is I'll just start recording. Actually, this is going to take lots of disk space, so you better have a big hard drive handy. So I'll just start recording, and I'll do a few swipe gestures. I'll do 1, 2. It's always good to do the whole thing a few times because it needs many examples of actually what you're trying to accomplish. Also, give it examples that are valid. That means that you say is a good thing to do, but also they should be varied in many ways. Yeah, they should be like I do right now. I'm moving here in a big way from the right to the left, but also like this here. So I think I collected some nice examples of the right to left gesture here. Maybe let's do some gesture from left to right as well with the other hand. Okay. I'll restart the recording. So, do the same thing. I'll take off my headphones for this because the cable is disturbing me. Okay. So, a few gestures of how I would do it in real life. It's probably a good idea to have not only one person doing these gestures, because I might be doing them the same all the time, but other people might do it differently. And that's why you should get a big variance in your data. That means get lots of people, try to let them make the same gesture over and over again, make a recording of this, and later on we will use these examples to create a gesture file.
Just a question there. Can you do like a more advanced, more thorough training with multiple people doing the same gesture?
Definitely. The thing is, for many machine learning a machine learning algorithm is just an algorithm that tries to figure out from the data what's actually in there. Yeah, and the thing is, if it's always the same person doing the same gesture, you cannot. It's not guaranteed that other people who might be doing the same gesture, but they have like different properties, like they are different in size, or they do it in a slower way or faster way, then you might not capture all the properties of this swipe gesture because it's only me who is doing this. So usually it's always a good idea to get a big variance in the data. That means try to find examples that are valid, that actually are of this class. Yeah, like this class is like the gesture from right to left, and this class is gesture left to right. Get valid examples, and the more is usually better, but not always. There's some kind of limit where it doesn't make sense
ratio,
to collect more data. But usually more data is good. But also it will take longer time to train the model afterwards. But what the model is, I will explain later. Okay, I'll just have a look at what I recorded right now. I just have to look where actually the folder is where I recorded this. You can look this up in the settings of this Connect Studio. Yeah, it's on C, Connect, in the vveekend workshops folder. Connect clips, vveekend workshops. And you can see this one here, I can delete this is from before. I have two files here now. They are called XRF file, and the R in here, that indicates that I did a recording in raw data. So when you look back here, since I'm doing the raw data recording, these files are called XRF files, but to use them later on to train some tests, we have to convert them into a smaller file format, which is called the XEF file format. But before I will do that, I will also rename these files. You know, the file name here is made up of the current date. Today is the 24th of April. And actually this time of day, I think it's not the Central European time, but the international time, whatever. But it's a good idea to just rename the file to actually what you recorded right now, because afterwards you might not know what is in which kind of recording is where. And then it might be quite a pain to figure it all out and look at all the files again. So I will call this just swipe left hand to right. And this one, the other one, was a swipe right hand to left. Oh, this one is still opened in the Kinect Studio, apparently. I'll just close it down for a second. Right hand to left. I'll just give you a quick demo of what happens if you don't record this in the RAW format. Because it's not necessary to record in RAW format. You can always take the smaller depth format here. You cannot record both at the time. So when I when I record the normal format, you can see that this RAW format is grayed out, so you cannot use this at the same time. And just to give you an idea, I'm going to do a short recording here. I'll stop this. Now, the stuff I recorded is an XEF file, and I think it's called extended file or whatever. I have no idea. But anyways, now we have to convert these files here into an XEF file. Well, if you are sure that Microsoft will never release an update to the SDK, you can always record this in XEF files format, but you will not be able to use this XEF file format in the next version that might be released by Microsoft. Who knows?
So they ditched the Kinect line at all, and they will implement all their technologies into HoloLens, which I don't think so that there will be any other SDK updates.
All the software that we're seeing here, the Kinect Studio and also the visual gesture builder that we will be using afterwards, it's pretty old already. Well, since if you put a lot of effort into creating a database of people who are performing some gestures, it still might be a good idea to be on the safe side, because if you have to do this again, and it takes some time to get all the people and do the recordings, it's probably easier to if you have this in RAW format and convert it, because the conversion step is actually not that hard. You can go on the Microsoft website, because you will get some command line tool which is called KS Convert, which is automatically there when you install the Kinect Studio. And actually it's pretty simple to use. You just need to say KS Convert, and then name the source file, name the destination file, and then it will be converted to this format. So we'll just do this right now. I will just open up a command line here. And yeah, it's in my path, so I just can say KS Convert, and then I'll just first. Oh yeah, this is one thing that's kind of annoying. That's where you can see that actually they didn't put a lot of effort into this. You have to give them the absolute path, because if I give the relative path, and you can see that I'm in the same directory as the files, and I'll just do swipe left hand to right and call it whatever, output left .xef. It will give me an error. So don't do that. You have to give the absolute path. So you need to say KS Convert. Then these files are on C, Kinect clip. Oops. In the weekend workshop folder, and here we have the swipe left hand to right hand. Is copy pasting in Windows 10 already working? This is something that was annoying. Oh yeah, it's working. But this one we don't need. And I'll call this swipe left hand to right .xef, and now it will do the conversion. Takes some time, depends on how large your recording was. You can see actually my recording I made, it was probably not even a minute, but it still has 4 gigabytes in size, which is quite a lot. So yeah, be prepared. Okay, it's done. Hopefully without any errors, because it's still not returning from the process. And you can see this one here, that the file that I just created is much smaller. So it's even less than half the size than the original file. But yeah, it's your choice. It's upon you if you want to create a raw recording or just a normal recording. I'll just do the same things for the other file. So swipe right hand to left. And xef. So we'll just do it a little bit. Actually, this tool can do much more. You can also do some kind of compression on the data that's inside, so you can use it for archiving of these clips. And yeah, since this recording was smaller, we're done already. Yeah, and this is now the stage where I have my data ready to use the other application that's inside the SDK, which is the Microsoft Visual Gesture Builder. As you can see, this program is still called, it's still named as a preview, so it's apparently not in a finished state, and this is something that we will see pretty soon, because actually it's pretty hard to figure out in the beginning what's actually happening in here and how to apply this program. This program here is for building a gesture database. A gesture database is what we will be using afterwards in our vvv application to load. So here in vvvv, we have here a node called gesture, and this node loads a gesture database. This GDB file is a gesture database, and in here we have the information we need to recognize the certain gestures that are inside this database. And this Visual Gesture Builder is the tool to do this. What you first have to do is you have to create a solution. This is the Microsoft terminology for a bigger project. Well, because why is it not called a project? Because it's possible that inside a solution there can be several projects, smaller projects. So people who know the Visual Studio will know this kind of terminology. And I will just create my solution where I created my clips, and I will call them swipes. Give it a double V, W, just for myself. So this here is like the project file, but there's nothing still in here. And now there's several possibilities how you can create a project inside here. And the project is meant to be a description for one gesture. Right now I did 2 gestures. I did the gesture from right to left, and I did the gesture from left to right. Or was it the other way around? Yeah, whatever. And so we will need 2 projects inside here to manage these gestures and to train our models. That means to give the machine learning algorithm the idea of what we actually mean by a gesture. What is a swipe gesture from right to left? And one possibility would be just to right click in here and say create new project. You can also do the same thing here in the file menu. And there's 2 possibilities of what you can do. There's the create new project, and there's the create new project with wizard. Actually, I'm not a big fan of wizards in all the applications I'm using, but for this here, I would make an example, because the wizard actually, it guides you through the stuff that you want to do. And it's sometimes not very clear of actually what you want to do now, because there's this possibility that you can do just one gesture with one hand and then mirror the data from the left to the right hand and use this for the opposite side. And when you do this just by creating a new project, it sometimes is not clear by terminology of what actually happens here now. So the wizard here is an exception for my hate of wizards. This one here guides you through the process. And you will probably do it right when you use the wizard. So when the wizard opens up, first I'd like to create a gesture that's my swipes that are from right to left. So I just call it swipe right to left. And I'm not saying which hand I'm using here, because on the next page, I can, oh, not the next page, but the page after that, this one here, it just asks me if I will be using also the body joints below the hips, that means my feet. Since I will not use my feet here for doing a swipe gesture, it's just a gesture that's managed by the hands, I will say no, because usually for many machine learning algorithms, it's very good to give it only the data where is actually some kind of sense in the data. Like here for the swipe gesture, my feet, they don't give any information at all. But if you give it this additional information, it will have a hard time to figure out if it makes sense or not. And if you by yourself say, hey, we don't need the feet anyway, just say no, yeah, and it will make it easier afterwards. So let's say next. This page here, it's about the hand state. You know, technique 2 can recognize if your hand is open, closed, and there's apparently also this lasso state, which I didn't know before that existed, because usually you can just say open and closed. We won't need this stuff for the swipe gestures, so we just say no here. And now comes an interesting part. This here is called the training mask, and the training mask is about selecting the body joints that we actually want to use for training a gesture. It gives you several possibilities. Yeah, the first one here says, hey, I want to use all the coordinate data that's up here in your upper body. That means the left hand, the right hand, your head, and your hips. This would make sense if you have like a gesture that's like a, whatever, like a kung fu style gesture, yeah, where both hands are really important. But here, for my gesture here, where I'm doing only a left gesture with my left hand and a right gesture with my right hand, I will probably take one of these gestures where only one hand is really important. So the gesture I selected here first now is, I think, my right hand, and the right hand, yeah, so I will just use this one here. This is something that I still don't remember now, because sometimes the Kinect mirrors your image. Yeah, because when you see yourself like in the mirror. And when it talks about the right hand, it's not always clear if it's the right hand that you have actually, or is the right hand that you see in the image. But since the image is mirrored, it's actually your right hand on the right side and not on the left side. You know what I mean? So rely on yourself. If it's the right hand, then just say right hand. So this one here is probably the one that we'll need. It is the one where it says ignore the left arm. Yeah, we will ignore the left arm and we use the right arm. But yeah, this one here is actually the right arm and not the left arm. Good. When we go to the next point, it asks us, do you need to know which side of the body this gesture corresponds to? Actually, yes, it's important for us to know if it's the right hand or the left hand. Yeah, it might be if you like do a boxing game where you just say, okay, I would just want to recognize a punch, and it's not important if it's the right hand or the left hand. I just want to recognize a punch. Then you can just say no, because it doesn't matter if it's the right hand or the left hand. This is because if it doesn't matter, then it will use the data that you created with the right hand, and inside the program mirror the data, so it will be the same thing with your left hand, which creates more training data to recognize the gesture afterwards. But for us here, we need to know that actually the right hand is the right hand, so I'll say yes here. Okay, and in the end, oh, I forgot to mention something. There's actually two kinds of gestures that the Visual Gesture Builder allows you to create. There's a gesture that's a discrete gesture. A discrete gesture is just a gesture where it says, hey, right now a gesture happened. Yeah, you don't know where you are inside this gesture, but you just want to know, hey, this just happened right now. Just you want to know a swipe, but you don't want to know where am I in this swipe, because this would be a continuous gesture, or as it's stated here, a progress gesture. There are some kind of gestures. There are some kind of gestures where you actually do want to know where are you in this gesture. Yeah, for instance, if I do a swipe from right to left, yeah, it might also be interesting for you if you are in the middle or at the end or in the beginning. But for us here, this is not really important right now. And we will not look into the continuous gestures today. We'll only use the gestures that are discrete. Continuous gestures is a thing that never really worked out really good for me. But yeah, maybe we'll give another workshop in the future where we look at the continuous gestures. So for us now here, we are not interested in gesture progress, so I'll leave this to no. And yeah, now this is interesting. Since I created a gesture that's my right arm only, it automatically creates two projects now, which is a project that's about my right arm, where I'm doing a swipe from right to left. And it does the same thing for the left hand. Actually, this is the one that I expected. This is the one that I used in the beginning. But as you can see, it will also create a second project where it will do the same thing, but on the left hand. Yeah, since this comes from the body side here, I said it's important for me that I actually want to know on which body side this gesture happens. And it's very probable that if you do something on the right hand side, that you also want to do it on the left hand side. So it will automatically create a duplicate of the project, which corresponds to the other side. So we will get actually two projects in here. And yeah, in the end, I will just say confirm. Before I say confirm, just notice here, it will automatically give a name, which is the name of the project that I said in the beginning, plus left and right, which will come in handy later on. And now I say confirm. And it wants me to save the whole thing somewhere. First, I will save the left project, just save it in this project, then the project with the right hand side, save it in the same folder. And in the folder, we will see that, where am I here? Weekend workshops. Now I got plenty of files created. First of all, there's this project called Swipe Weekend Workshop, which is the solution. And then we got two projects, which are called left and right, which are these files here. Here's the right project, and here's the left project. And also some other files that I will explain later what these are for. So it's quite a way to get to a state where we can tell the program the gesture builder, where are my gestures? Because right now we don't have any data inside here. So what do we need to do next is we have to select one of these projects. I'll take the swipe right to left for my right hand side project. And now I need to get the recordings I did before and just drag and drop them inside here, or just right click in here and assign this file that we recorded which is swipe right hand to left, and doesn't want me to drag and drop. Okay, I'll just add a clip by right clicking in here. I'll add the clip right hand to left, and in here now you have this clip that we recorded before, and you have to here you have some kind of timeline, but you cannot just play as you're used to in a video player. You just have to click on this bar here to drag around this clip, and here we can scroll through the recording that we made before. So what's next? Since machine learning is kind of learning by example, we need to tell him actually where are the parts that are really important to me. So that means sorry, I'm a little bit confused right now because this is my right hand. Oh, that's fine. Okay, I need to find the spots where this gesture I'm doing is actually happening. So you can see here, this is the important stuff. And now is a good point to look down here, because there's lots of keyboard shortcuts that you can use when you want to select these gestures. Yeah, you can use your arrow keys to scroll left and right. And if you want to select one of these parts here, you find the exact beginning of this gesture. Well, it's hard to tell where is the exact beginning. I would say the exact beginning is here, where I move my hand from the right to the left. And by holding the shift key and using the arrow keys, you can see I can actually select this part of the video. So this green overlay indicates that I have made a selection. And if I wanted to tell that this one here, this part I selected, is a positive example of the gesture that I actually want to train later, you just hit the Enter key, and you will see that there suddenly is a blue marking on top of here. So you can see it will rest also if I move this whole thing. And I know this one here is part of the gesture, and later on it will say, okay, this is the part where I have to look at to actually see what's going on here. If this is a gesture that's interesting to train or not, he will not know if we don't tell him, and this is the way to tell him. So I will just scroll through the video I created, just using the arrow keys. Okay, so we start here. I hold the shift key again and hit Enter. Go to the next one. This one here probably is also a gesture. Microsoft says it's pretty important that you only take really the stuff, the frames that are necessary to recognize the gesture. So this one here probably starts somewhere here. Hit Enter again. And yeah, as you can see, this all takes some time, but by using the arrow keys, you it's not as bad. This is another gesture that's kind of interesting because I'm not moving it very far. Yeah, and this takes some time. Okay. Now what's important? If you think that there are some gestures that are not very well made, or well, you probably should take care when you record already that you're recording some clean gestures, yeah. Because if you got some data in here, like a gesture like this one here, and you don't mark it as a gesture, then the machine learning algorithm might become confused afterwards, because this one here looks pretty similar to what I did before here or here, and if you presented the same kind of data, but I will tell him one time, hey, this is not a gesture, and the other time, this is a gesture, then it will be confused in a way, and it will probably try to find different information in the data to actually make a sense of what I'm doing here with my hands. So you really have to take care of that and mark all the gestures that you have in here. And what I did just right now is the opposite. By hitting the space key, I told him this is not a gesture. This is a negative example of the gesture I tried to build here. So you can, by pressing the enter key, you can tell him, hey, this is a positive example. And by pressing the space key, you can tell him, hey, this is a negative example. So this is absolutely not what I'm looking for. But in this case here, I was doing something wrong. Okay. So this is kind of boring work, especially when you work with like, think of 10 or 20 people. It's hard. There's no rule of thumb how many people and how many gestures you need, because some gestures are easy to detect, some gestures are much harder to detect, and you just have to try out and figure it out yourself. So there's one more.
I can imagine in a bigger company this kind of work has its separate department. So there are dedicated people who are doing this kind of job.
Definitely, yeah.
For game development, for instance.
I guess if you're in a game development company, then it's probably the interns that do this kind of stuff.
Yeah, I can imagine.
Yeah. And the thing here is, now I think I marked all the gestures that I have in here. And if I only give him positive examples of what I'm doing here right now, it will think that everything else in here is a negative example. So it will try to separate these. If you give it negative example by pressing the space key, to be honest, I'm not sure of what it's actually going to do. I'm not sure if it only will take this one as a negative example and all the rest as well or not. But I think it will still take every frame that's not marked as a negative, not marked as a positive example as a negative example. And yeah, if you mismarked something, you can just hit the delete key, and the gesture will be gone. The marking will be gone. Okay, so now we have collected some samples and some examples, and now might be a good idea to try out actually what we learned now, or what we marked here right now. And now comes an interesting part of the whole thing. By the way, you can add more than one of these video clips to one project. So if you have several recordings of several people, you can just add another. It wants me to save the whole thing. Yes, I do want to save. You can add other clips here. So you can have multiple clips in one project, but all of them should be from the same gesture you're building. So if you have several people doing the same gesture, just put them all in one project. And in the end, when you say, okay, I marked everything that I needed here, you just right click here and you can say build, which is actually kind of a strange word, but it comes from programming world. Actually, what we're going to do now is we're going to train the machine learning model. That means we're trying, we're feeding the data to the machine learning algorithm, and it should try to figure out where is actually, what is important from this data that makes up this gesture that I'm performing here. And as soon as I hit build, there's come some interesting output that we'll see immediately down here. And what I'm building here is a gesture analysis database, which is a GBA file, and just save it somewhere. And suddenly down here, we will see lots of output from the visual gesture builder. And we will have a look of it, what happens in here a little bit later, because this is really interesting what's actually happening in here. And after a few seconds, it says, okay, the build completed successfully. And now we have this gesture analysis file. And what's cool now is, since we have this gesture analysis file, we can also test it out ourselves. And that's easily done if you just right click here again and call the live preview. which is kind of good to debug of what you actually trained right now. We just made a model. The machine learning algorithm figured out what is important here and what might be useful to recognize this gesture. And by using this live preview thing, we just can try it out if it actually performs the way we expect it to perform. So when calling a live preview, you have to feed it one of these GBA or GBD files, open them, and you will get a big screen where you can actually perform gestures just trained live. And this window here is actually a graph that tells you the confidence. That means how probable is the gesture that we just trained performed right now. So when I'm standing right here, I'm doing nothing. You can see there's nothing in here. But when I'm doing this gesture, actually nothing happens. Oh, it's because, yeah, this is what I was telling you about. Actually, I thought I would be training the right hand, but it's actually the left hand I trained. It still confuses me. I'm still not sure where's what. There is probably a system behind it, but at the moment I am not sure of it. But you can see, if I do stuff with my right hand, yeah, or with my left hand, nothing happens. But as soon as I do this gesture here, you can see there's this graph that tells me in this moment, how probable is it that I perform this gesture, which is kind of cool because actually there was not much logic from my side involved. Yeah, I didn't have to tell him, hey, when the hand is on the left side and moves to the right hand side of my body, or if it is in this angle to my body. Yeah, so what you would usually do. But I just gave him examples and he figured out himself what actually makes up a gesture. And you can see all these little gestures I perform are recognized. Some of them are better recognized, some of them are worse recognized, but they are still recognized. Yeah, and I can do stuff with my hand here now, and yeah, there's no gesture. So actually, this result is quite good. Okay. When we are finished looking at this live preview, I'm quite pleased with the result I got here right now. Now I should probably do the same thing for the other hand, which is now called left hand, even though I will probably use my right hand. So if I add my clip here from the other side, I was using this here. I have to do the whole thing again for the other gesture. And there is also a possibility to mirror the data that you got from left hand to the right hand, because usually you would assume that what I'm doing with my left hand for a swipe here should be the same data for the right hand. But yeah, as you can see, I'm a little bit confused of the naming of right to left and stuff like that. And there's one other thing which is hidden by the video here that I could show you. When you have these projects here, oops, now it's gone. There is some stuff that you could probably adjust during training. Yeah, for instance, this is some kind of a project properties tab or whatever, and most of the stuff you probably don't understand right now, but there's stuff like yeah, the stuff that we actually set in the beginning in the wizard here, like do we want to ignore an arm? Yeah, and here in this project we ignored the left arm, and the right arm were used, even though I was actually using my left arm to perform the gesture right now. So this is kind of yeah, I'm not really convinced of what the visual gesture builder is doing here, but maybe it's just me. It's also very much possible. Okay, so for this gesture here, I will not do the same thing for the other gesture here, because this is taking too much time. For this gesture here, I created one of these .gba files. So as soon as you build a gesture, you will get one of these, where is it? Here, the .gba files. And this is a gesture file that you can also use already in your Kinect application in vvvv, because this gesture node here, it takes either a GDB file, which is a gesture database, or a GBA file. The difference is that a GBA file just uses one gesture, and a GDB file can contain some gestures. Like here, when I have a solution and I would right click and say build, then it will build all the projects, all the gestures that I have defined in here, and make a GDB file. And this file then contains all the gestures that are inside. And the GBA file, on the other hand, just contains this one gesture I trained right now. So what I will be doing here right now is I will try this out, the gesture I just trained. Where is it? It's here in the weekend workshop. Here I trained this .gba file. I say open. And this gesture node that comes with the Kinect pack by Vux, it will give you on the first IO box the name of the gesture that we actually created here. So we had this swipe right to left, right, and it will have the same name here. And since I'm only using one gesture in here, I will only get one output for a detected gesture or not. And this is also interesting here. The gesture node not only delivers the name, of course, but also whether or not the gesture was detected and what gesture confidence we had. Sorry, it's gone already. The confidence, again, is what we saw right now also in this preview node. The confidence is how probable was this gesture performed right now, the probability you get as well. So we might introduce some threshold inside here. And yeah, let's just try out. No, this view doesn't update very well.
Yeah. I wanted to tell you just to...
Yeah, I just noticed. So, this logic down here is just a little logic to only consider parts of the movement I actually make, and from a certain, yeah, I'm just recording the stuff where he actually detects some gesture. And I will also just take the largest, like the maximum of the gesture inputs here, and compare this largest detected gesture, because this is a continuous thing with a threshold. And then in the end, I'll just introduce the monoflop here just to visualize that actually this gesture happened, because it does these comparisons every frame. Every frame I do something, it will try to find a gesture. And so these values here, they can change pretty quickly. And sometimes you miss a big value, even though it was there. So this queue in here is just for accumulating the last, how many frames? The last 54 frames it was here. It's a dynamic counter that increases the queue length and takes the maximum from here. And in the end, a comparison is made and just visualize with a monoflop. And yeah, to use this, I have to enable the Kinect, but for being able to enable the Kinect, I have to close down the Kinect Studio. And now, if I'm right, yeah, the Kinect is started, and let's perform some gesture. Oh yeah, you can see. Of course, this is not right because we only have one gesture in here. You can see that actually this swipe gesture is now recognized, and you can see that sometimes it's recognized or seen very small, yeah, because if I'm just doing something here, it might not be very confident that it's actually the gesture that I'm using here, but if I'm doing the real thing, then the values will be very high. So this threshold here is just a very simple way of filtering out the results that are not really a gesture. So, and well, actually, that's about it. That's the whole magic behind gesture recognition by Microsoft with the Kinect SDK. So If you wanted to create an application that has more than one gesture, you would probably do the same thing with the other gestures, what I did right now. You just load in your files in here. You do some annotation. Do some annotations by scrolling around here, using the arrow keys, finding the places where this gesture actually happens. Just select them with the Shift key, hit the Enter key. Try to find all of these. Then as soon as you've done it, it asks you to save the whole thing, because actually what he stores is an XML file where it says which frames belong to which. Oops, what happened now? Oh yeah, which frames belong to which class. Is it a gesture? Is it not a gesture? It's just a binary decision we're doing here. And in the end, we can build the whole thing. And what we will get is a gesture database that contains the description of what actually this gesture is performing. And yeah, I'll just open up a file that I prepared earlier, which is actually, I think it's, I think it was here. No, here in recording, I guess it was. There's a GBA file. There's a GDB file. So when I open up a GDB file, in here I have two gestures that I trained earlier. And yeah, now I can use these to recognize some gestures.
Okay. Your camera is hidden now as well, so we can't really see what you're doing.
Okay, sorry, thank you.
Yeah, I don't know why you suddenly decided not to stay on top.
Never mind. Okay, so I'm performing the gestures here. You can see the cool thing is, well, this one I created earlier and I didn't put a lot of effort into finding the gestures. Actually, what you shouldn't do is react on stuff that where no gesture is actually happening. That's what something that annoys me is when you create a gesture database and then it triggers all the time when the gesture is actually not happening, because that's what you don't want to have. But actually the gestures are detected pretty stable. Yeah, but this one is also detected, and that actually should not happen, because if you recognize everything as a gesture, then you didn't learn many things. Okay, so this was, well, I would say the practical part of this gesture recognition in with the Microsoft SDK and vvvv. I think now it's maybe a good time also to look a little bit behind the curtain of what is actually happening in here and how these gestures are being recognized. Or what kind of data he actually uses to recognize these gestures, because this might be also a good thing to take in consideration when you design a gesture, because there are several gestures that are actually not really easy to recognize, or even impossible to recognize. But Microsoft doesn't tell you this. It just tells you, hey, you can do gesture recognition. But I read through all this stuff, and I'm pretty sure that some of the gestures, like complex stuff, like doing a triangle or stuff like that, is actually not one gesture that you can perform and record, because it will never work out. Actually, if you have complex gestures, you have to split it up into several simple gestures. Like if I would make, sorry, you cannot see me again. If I would make a triangle like this here with my hand and say this is a gesture, then this toolkit will have a pretty hard time of figuring out actually what I'm doing here. And it might be a better thing to actually split this gesture up into several parts and doing one gesture like this and one gesture like this and one gesture like this. And then afterwards, apply some more logic to, well, some kind of automata to find out, did the first gesture happen after the second and the third gesture? The other way. Did the second happen after the first and the third after the second gesture? Because the Connect toolkit in this sense here does not recognize gestures that are complex like this. So not everything's possible.
So you can't really assign a gesture for any special kung fu or karate movement out there?
No, you can't, but what you can is you can try to split it up into several pieces of gestures and apply some logic afterwards to tell him actually what piece has to follow after which piece.
Okay.
So there's lots of limitation with this, and this is probably also one of the reasons why actually Microsoft never did did try to improve what they actually made here, because it's pretty hard, I guess. Okay.
Yeah, it seems to be pretty vague, and you have to experiment a lot to get the result what you want, it seems.
Definitely. Okay. I'll just try to reduce the size of this here, and I will just look at some data now with you that we get as output from the visual gesture builder, and I will talk some theory, actually what is happening here for the machine learning part. What I'm having here is the slides that I used for my workshop that I had in Note 15. And I'll give you a simple theoretical view of actually what machine learning, in the way we're using it right here, is doing. As I told you before, machine learning is about learning by examples. Yeah, and this graph here is a simple model or a simple graph of actually what's happening. So what we have in the beginning here is some data. We collected some samples, some examples that we recorded, and we also did an assignation, as we did some classification of this data. So we told the machine learning algorithm, actually, this part of the video belongs to this gesture, and this part of the video doesn't belong to a gesture. And for other gestures, we did the same things. So we have the original data, and we have the classification of this data that we, as a human, gave the computer. And those two things we feed into some kind of learning algorithms. There are plenty of learning algorithms, like hundreds of them. And which one to use is here not up to us, because this is something that's ready made by Microsoft to be used in an easy way. But when you yourself design something like this, you have to try out lots of stuff, what works, what doesn't work. It's not always an easy task. Usually it's a very hard task even. But the learning algorithm will try to figure out from the data that we provided actually what makes up this class. Yeah, so we provided some classes and we provided some data, and they will try out, okay, what is there in the data that makes up this class, and we'll try to learn a model. A model is kind of a black box, kind of some data that can be used later on. If we have some data of an unknown sample, unknown class, like we perform a gesture live, the model will afterwards tell us which class this sample actually belongs to. So this is pretty simple. First, we do the training. The machine learning algorithm creates a model. The model would be the gesture database or the GBA file. And afterwards, when we feed some unknown data into the model, it will tell us which class it does belong to. Or not even say, well, it belongs to any class. But there's several kinds of machine learning algorithms. The algorithm we are using here right now is just a classification algorithm that knows two classes, which is it belongs to the gesture or it doesn't belong to the gesture. And that's all we get. We get some confidence as well. So there's some probability as well involved. But this is pretty straightforward. And now it's interesting, okay, what actually is happening here? What does the data have to look like to be able to use by the learning algorithms? I told you before that in the Connect Studio, we actually do not only a recording of the infrared or the depth image, but we also do a recording of the skeleton, which is something that we are provided already by the Kinect SDK. As you can see here, it's not only the depth image, it's also the skeleton. And why is the skeleton data better than just the depth image. We could also just use the depth image as input data for doing gesture recognition. The problem is that this image here, or the depth image here, has lots and lots of data. So it will be like, I have no idea, I think it's like 512 by 400 something pixels in the Kinect 2, which is like, well, hundreds, thousands or millions of pixels. And each pixel contains some information. And this is lots of information. Compared to the skeleton, yeah, the skeleton consists of, I think, 25 joint positions. And each position has 3 coordinates in space. So it's like 25 by 3, which is, 75 data items, I can call them. And 75 is much less than, well, having a few 100,000 or millions of data pieces. Because in the beginning, the machine learning algorithm doesn't know where to look at and where, actually, which part of this information we have here is actually important for this gesture. And yeah, so the skeleton is some kind of data reduction algorithms we applied before. And if you only give it meaningful data, or if you give meaningful data to the algorithms, then it might have an easier time to find out actually what's important and what not, yeah? Okay. The coordinates of the joints here is the one thing. But the stupid thing about coordinates is that, well, they're kind of absolute. So, meaning if I would be standing here in space and doing a gesture, then yeah, it could be that my left hand would be at coordinate -1 and +1 in height. But if I would move to the right here and stand here and do the same gesture, the data values would be much different, yeah, because I'm not standing here on this side, but on this side, even though I'm performing the same gesture. So the coordinates themselves are probably not the best way of describe what I'm actually doing. So it might be a good idea maybe to make the coordinates not absolute, but relative to something. For instance, make the coordinates relative to my body position. So as soon as I move over here, the hand would be still relative to my body center. And yeah, I would get similar data by doing the same gesture, even though I would not be standing here, but here on the left-hand side. So I would do some kind of transformation of the data, or I would try to transform the data in a way that it's less error prone. Less error prone in the sense that no matter where I do this, or no matter how fast I will be doing it, it will still look very similar. Yeah, and everything that we make easier for the algorithm to understand, it will have an easier time afterwards to figure out what is actually important and what is not important. And the coordinates, relative coordinates, is just a simple example. Actually, when we look into the output of the visual gesture builder, we can see that it actually uses much more than only the coordinate position in space, or what he's calling here the differential position is the relative position of the coordinates in space. What he's using here, he's using 38 what he calls features. Features is data that we can feed the learning algorithm to make sense of the data. And he not only uses coordinates, but he also calculates some other stuff. He calculates, for instance, the angles of the limbs. Yeah, for instance, when I got 3 limb positions here, I got my hand, my elbow, and my shoulder. I can calculate between these 3 here an angle. And what he does, he tries to figure out many angles between all these body positions I have. Like, for instance, the angle of my head to my hand to my hip, for instance. Yeah. This would be an angle that might contain some meaningful information, because think of my swipe gesture. Yeah, my swipe gesture probably also always looked in a way that I would have my hand like this and move it like this. So this angle here probably always is in a certain region of values, like in a region of a right angle, or in the region of like a little bit less than a right angle, but it will never be like this, for instance. So this is some kind of data that may be useful to the machine learning algorithms. Also, let's look at some other features he tries to use for doing this gesture recognition. Yeah, for instance, velocity. Probably this is some kind of frame difference thing. Yeah, he will compare when I'm moving my hand in space, how fast are the differences between two frames in X, Y, and Z coordinates. Also, the angle velocity, which probably is how fast the angle changes. And this is interesting. This is something that apparently in the Microsoft SDK, but is not available for the normal user. This would be great if we would have this in vvvv as well. It's possible for the machine learning algorithm here to use some feature called muscle force. I was just talking to MicroD before. When the first demos of the Kinect 2 came out, there were some demos of a guy standing on one foot, and you would see from his foot that there's actually they calculate some muscle force, like the force you would use to do some movement, yeah, which would be a great feature for us to use as well, because if you know how much force you have to use to do some certain movement. That would be great to have, but actually there's no way of getting it. But inside here, this visual gesture builder, it's actually there. Yeah. Then there's again some differential muscle force. What's there? Well, the velocity squared. They just square the velocity. Maybe the data comes in a different different range that's easier to analyze for the algorithm. We got accelerations, we got hand values, where hand value here is about whether my hand is open or closed. But since we said in the beginning that we actually don't want to use this, it says here it's excluded. So all in all these features that the Kinect SDK calculates in the background, they add up to over 3,000 features that are used for training a model for this here, yeah? Because everywhere in here, there might be some useful information, but much of this information might not be useful at all. And a hard thing for the machine learning algorithm is now, which of these informations is actually important to me? And what it does afterwards is, he will do some kind of feature selection. That means from all of these features, from these 3,000 features that we have in here, he will try to do some kind of ranking. Which of these features are actually more important and which of these are not important at all. The sad thing is the only thing that we get as an output is that are the top 10 features that he used in here. So these top 10 contributing weak features are the muscle torque, muscle force, the angles, the velocity in Z direction from the spine, which I have no idea why this could be important, but well, it's up to him to decide what's important for him to recognize it. And
maybe the angle of the spine. So, for example, it won't recognize the gesture if you are bending right to left.
Yeah, probably. Yeah, that's. But I didn't. Yeah, well, that's true because there was some data where I would bend over to the computer, and I gave it as a negative example, or I didn't mark it as a positive example. That's why it was negative, and that might be an information for him to say, hey, this is something that actually says very, very thoroughly that is this part here is actually not important for me. So. Or for instance here, angles of the head, shoulder left, and spine shoulder. It might also be an angle. That's head, shoulder left, and spine shoulder. This is the center of the shoulder. That might be important to him. But he will probably use many more than these features. But he only outputs for us the top 10 contributing features. Yeah, and that's about it. So it's hard to tell what actually is going on in the background. Microsoft doesn't open the technology behind it. I did some research and they won't tell us. But yeah, this is the data that's behind this. So what you can see is when you actually want to create machine learning algorithms, you have to think of, okay, what kind of data can I present this learning algorithm that actually says something about the stuff I want to classify here. And I think in the next workshop where we'll have a look at the machine learning pack, I will talk a little bit more about this one. But here, for giving you a soft start into machine learning, this might be interesting to see what's actually going on. So to sum it all up, what happened here is we do some kind of feature extraction. Feature extraction is trying to get some meaningful data. So first part of the feature extraction would be get the skeleton from the depth image. Yeah, because the skeleton is a much lower dimensional data than the image, because the image is like hundreds of thousands of values. Skeleton is less than 100 values. So this is a feature reduced model. Also, from these features, we maybe can calculate some other features like the angles or the velocities or whatever. And then we use these data that we just collected, these feature data, and feed them into a learning algorithm, which creates a model. I will just search for a different slide where I have this. Yeah, here, that's a little bit extended here. So what I was talking about right here is, first we get the raw input data, which might be like the depth image that we have here from the Kinect. Then we do some feature extraction, which is try to get some meaningful lower dimensional features. Lower dimensional in the sense that we have less data, like not hundreds of thousands of pixels, but like coordinates of a body, which is like hundreds of values. And also, we have to tell him, okay, which class do these features actually belong to? Or does this example that we give the learning algorithm actually belong to? And then in the next step, the learning algorithm will create a model. And when we want to use this model to recognize some things, we will also get first the raw data. We will need to do the feature extraction as well, so that we have the same features as here before. And we can use these features on this model. And this model will hopefully tell us whether or not this example that we just presented belong to class A or class B or whatever. And yeah, as you can imagine, there is many things that can go wrong here. Yeah, for instance, if you select the wrong features, yeah, if you say for a gesture where you want to track your hand movements and you presented the head and the feet, head and feet and whatnot, the machine learning algorithm might have a hard time to find actually make some meaning of the data that we presented to him. Also, the machine learning algorithm might not be capable enough or intelligent enough to figure out what's in the data. So it will produce a model, but the model might not do what you would expect it to do. Yeah. And so this process here is like an iterative process. Yeah, you do some stuff and you have to test it again, and you find out, okay, it's not working that well. Maybe I should do it again, but with a different feature set or different data processing than I do before. And often it's a good idea to collect lots of data, try to get a feeling what's actually in the data, like how do the values look like? Are they large or are they small? What do I have to do to the values? For instance, do I have to transform them? Yeah, because coordinate data that, well, is in the range of meters might not be the same data like angle data. Angle data is in the range of 0 to 180 degrees, for instance. And 180 is a much larger number than like 2 meters. And so you would have to normalize the features so that they're all in the same range. So they're all kind of, they all have the equal rights with the machine learning algorithm afterwards. Yeah. But I will go into more detail about all this later on in the next workshop. Where we'll talk about feature spaces and actually what's behind this whole machine learning thing. And we will have a look at several of these algorithms that actually can be used. And I will try to find some examples where this magic here can be used for different applications inside vvvv. Okay, I would say it's now time for some questions. I'm not seeing the stream at the moment, but David, can you tell me, are there some questions on Skype or on the stream or?
Actually, not too much.
Not
Only
too much.
Tom Film said in the beginning then that you can shift right click on files and it will add up. So yeah, not too much. But if anybody has questions, this is the best time to tell us. I want to note here that we have like a 10-second latency to the video. So
not a problem at all.
I'm telling also to the writers that we have a kind of a delay of answering it. Yeah.
Well, I will just use this time to say thank you again to Books for creating these Kinect nodes. I'm not sure how many people actually use this gesture node. It might be only a few, but still, just that he implemented them, even though there's probably not yet many people who are using this, is kind of cool. Thank you, Books. And also thank you to the devs, of course, because they're creating a cool toolkit like that, where it's kind of easy to, use all kinds of cool devices and make programming easy as it is. Yeah.
Actually, I think vvvv comes at the best when you compare how fast it is to integrate hardware into your program. And
that's my experience as well, especially when it comes to some devices, thanks to guys like Books and you, MicroD, for instance, for the Leap stuff you did. It's especially when it comes to natural user interfaces, I personally think that it's pretty, it's the quickest way of trying something out and getting a prototype ready and trying out stuff that can be actually used in applications. Also, this combination with the Visual Gesture Builder here, for instance, trying to get stuff into an application that is about user interfaces and natural user interfaces, this is probably the quickest way of doing it, I know.
Yeah, it's just be careful with not developing these very awkward menus. I see a lot of times that people are creating, for instance, these Kinect-driven buttons where you have to use your hand.
This one.
As the cursor and these kind of gestures, and so you have to be very careful not to fall into that error. To just know very much what the situations are.
Definitely.
Yeah.
My experience with the Kinect is also that it's pretty cool for many things, but for instance, one of the big limitations is that the skeleton tracking always assumes that you are standing frontally to this Kinect. So many interactive applications, especially when it involves dancing and stuff like that, they will really have a hard time doing the skeleton tracking and use this in a meaningful way. So this is something I'm really longing for, some kind of tracking device or algorithm behind a tracking device that makes it possible to do a full body tracking also when persons are moving and rotating and lying on the floor or doing stuff that's not just in front facing the Kinect frontally. Well, that would be really cool to have.
Requires kind of a studio, and there are kits like this, but that that requires a special clothing. And like
and that's why it's
18,000
almost impossible to use. There's systems, motion tracking systems like they use for motion tracking for films by vveekend or whatever the name, but they cost like hundreds of thousands of euros, and you have to apply some balls on it. And what's cool about the Kinect is you can just walk in there, you're there. You don't have to do anything to your clothes and put on any markers or stuff like that.
I think Microsoft are kind of researching now a way of doing this. With HoloLens, they had a demo video where they called it holoportation or something very, very punny name. And but the thing is, they still had to set up multiple cameras all over the room. Not as many as a traditional motion capture Hollywoodian thingy, but for instance, 8 cameras or something like that. or other candidates might be the thing what Valve is doing with HTC, but that's called the device itself. So it rather attacks the device than the user.
Mm-hmm. Well, it's clear that a camera that's only seeing one part of the room cannot see everything. So as soon as you hide yourself or hide a part of yourself, then it cannot see the same thing than if you have several cameras. But even having several cameras, or at least the possibility to use more than one Kinect device or Kinect 2 device on one PC, that would be a great improvement. So I was hoping for solutions like that, because having to use 3 computers for 3 Kinect devices is kind of a pain.
But yeah, actually, you can do multiple Kinect ones on a computer, not Kinect.
You can up to 4, I think. Up to 4 work. But the Kinect 1, well, there's other problems involved using multiple Kinect 1s as in the same space, because the infrared pattern it emits, it might interfere with other Kinects that are already there.
Oh yeah,
but there are some tricks like rotating or moving motors on the Kinects that will kind of blur the image, so they won't interfere. I read some paper on that, but
oh wow. So Randa Vasquez says no questions on his end. Just wanted to thank Motzi for all the good stuff.
Hey, Randall.
Yay.
Cool that you have no questions, because either that means I explained good or nobody understood anything at all.
Well, I think you've done a pretty good lecture on this. You're a university teacher, so you have much practice in it. So you explained it in a very good manner.
Thank you.
He also said that he will sure tune in for the next workshop, which will be next weekend, right?
The next workshop will be next weekend, probably also on Sunday. Sunday, same time, Sunday late afternoon, early evening. And next time we will look into the machine learning pack that I created and try to figure out if there are several applications that make life easier, like this visual gesture builder makes maybe life easier. I have to warn you, what I showed you right now, it looked all pretty easy, but you will find out pretty soon that there's lots of stuff that you need to tweak until it really works well in the way you want it to be. So it's not just necessary to build the gestures like in here, but you also have to do some post-processing afterwards, some thresholds you have to apply, maybe some other logic, but it can be useful for many things.
Awesome.
Yeah. Also, I will probably post some links to some videos by Microsoft where they actually explain how this gesture builder works. If you're really interested in this, you better have a look at these videos, because they go much more into detail of actually how to use this tool. And of course, it's not connected with vvvv, but all this part that we did here, of course, it's the same, because in the end, we have a gesture database, and this gesture database can be used to any applications that uses the Kinect SDK.
Yeah, it's more computer science stuff, so which also applies to vvvv as it's a kind of a language.
Not necessarily. The videos I was thinking of, I can show that. You can find them on channel 9. And if you just do a search for visual gesture builder, apparently there's more than one video, but I think I was talking about this one here. Yeah, actually, I think there's even 2 videos, and they walk you through how to use this application. And that's a good way to get more knowledge about what's actually going on and how to use this thoroughly. Because as I told you before, my experience was that it is really kind of painful in the beginning, because it's not very well documented. You have to read through lots of stuff. But if you follow the steps I did before, I think you will get to a result. Yeah.
Awesome. So do you have something else for us to tell, or We should call it a day.
For today, I think we should call it a day. You'd better try out now your new knowledge you just gained. If you have a Kinect handy, just give it a try. Just remember when you use this toolkit here, this right-left hand thing, I still have to look at it again. Probably there is some kind of logic behind it, but I just don't get it. And
that can be confusing.
Just remember, read through the shortcuts down here, how to navigate through it. For instance, for me, it was really hard in the beginning because this one is not very well programmed. If you want just to scroll by clicking not on the bar but somewhere else, it will jump there, but it will not scroll, which is kind of weird to me. You have to click the bar, then you can scroll through. Use the arrow keys.
You have to hit that 3x3 pixel bar or 3 pixel
bar. That's not a very well designed user interface. You have to click directly to scroll through. If you don't do this, but just click somewhere, it will jump there, but it will not move anymore.
Well, actually, from vvvv, we are trained to hit 3x3 pixel points. That won't be.
Yeah, that's why after I found out how to use it, it was not a problem at all. But as a trained vvvv user, I'm pretty good in using all the buttons the mouse ever has.
Also, Glass Suns at Night says about the dancing example you were talking about. I was asking myself if it is only the gesture recognition part isn't working, or also the skeleton raw data is not working when not facing the cam.
Actually, when doing dancing, I personally believe that it's pretty useless to try this gesture recognition and stuff that I just showed you right now, because the movements that are involved in dancing are so much more complex to these simple movements we did here. As I told you before, even like a simple triangle gesture is not one gesture, but rather 3 gestures. And I think it's pretty hopeless to try to go into this for dancing. But also the skeleton recognition itself is some kind of machine learning process that is actually applied here, and it will fail if you will not be standing straight to the camera, which is a sad thing, because it should probably be possible to achieve more than that, what the SDK delivers us.
Well, if you are kind of rotating from the camera when you were standing frontal to it before, it can actually keep you very good. Obviously, the limbs which are in cover won't be recognized that good.
But as soon as you sit on the floor, or as soon as you turn around, it will recognize you. Not, of course. How should it know that? Maybe by looking at your face, because it can do the face with the Kinect face. But as soon as you turn around fully, and that's something that happens all the time in dancing, then it will still assume that you're frontal to the camera. So. That's something that should be addressed in a way for more interesting applications. You should also say that Kinect is a consumer piece, and it's a great piece of hardware for little money, and what you get for it is quite cool in my opinion. But it doesn't solve all the problems that we actually would need to be solved for interactive applications like dancing.
Yeah. Also, he responded that I was guessing if the skeleton data would be working, then the features could maybe be normalized concerning the rotation of the body. I'm not sure what he meant, or she, or I don't know. So I think I have a better idea what they meant.
Well. Feature normalization in this sense here, I'm not sure if I can make sense of it. I would say...
I think he references the part when you were telling us, the degrees and the meter scale. So the scale of the data have to be normalized from multiple sources. If you have data coming from multiple sources, they have to be normalized into similar scale.
That's true, yeah. And of course, if you get if you have multiple sources, then you also have to find out which of the sources is actually right and which is wrong, because that happens all the time. Because if you're standing sideways to one camera but frontal to another camera, one camera will tell me some shit, and the other camera will tell me some good stuff. And to figure out actually which one of those is right or not is also a different part that you have to consider.
Oh yeah.
So.
That is.
I mean, you get the information if the limb is inferred or if it is tracked, but that's something. But it might not always be true.
But I think that is venturing into computer vision as well, which is another topic in itself. And I think I guess that Microsoft using machine learning techniques and computer vision algorithms working together very much.
Definitely, yeah, especially for their HoloLens stuff.
Oh yes, indeed.
Which we hope will be containing much better stuff than this year, because this is all about tracking persons and telepresenting persons to a different space. Is all about tracking and doing some movements with your hands and stuff like that. So I'm pretty sure there will be much better applications in the future.
The thing is that I'm pretty worried about the HoloLens, because they not present us very precise features that what this device will do. They only presented us videos that this is tracking here, this is tracking there, there's lots of camera 3D tracking, and then 3D everything, 3D in the world, but not on what are the exact specific features this device can do, what will recognize, what it won't recognize, etc., how we access this data, whatsoever. I don't really like when companies doing this.
Well, it's kind of advertising. I mean, of course, you have to create some hype around your product you're creating. Or, well, one of the products that I'm also looking forward to is like this Magic Leap stuff, like where you have a display that actually can do depth imaging.
That is very much more vague. I think that will be a vaporware. I don't trust.
I have no idea. But that's the thing. You have to create a hype first to make people interested in your product, and if they're interested, then you can push your developers to really, make some good stuff out from it. But yeah, I'm pretty sure it's the same like the Kinect 2. In the beginning, we had some demos of many cool things that should be possible, but as soon as you have the thing in your hand, you find out pretty soon that its possibilities might be limited.
Yeah, it's like half the story of what the advertisers suggested only.
Yeah, it's always the same like this. But I'm pretty sure stuff will improve in a way, but some stuff will take less time, some stuff will be taking more time. And especially when it comes to machine learning, there's this deep learning thing, deep neural networks, methods that allow you to create an artificial neural network with several layers. I will maybe talk about this next week. This is one of the great leaps that has been achieved in the last 5 to 10 years, where the results you would get from classification and recognizing stuff improved radically, so much that it's now actually usable to use voice recognition and image recognition, perform image recognition on data. And the reason for that is that actually, first, the algorithms to train these models they improved a lot. Also, the computing power that's necessary to train all this is suddenly there, because we got massive parallel computing with graphic cards. We also got access to lots and lots and lots of data. Or not us, but companies like Google or Microsoft or Facebook. They got I have no idea how much data actually exists in their data storages, but they can use this data to improve their models, and suddenly it makes sense and it can be actually used. And this makes some interesting developments for us, our society, because as soon as computers become as capable in recognizing stuff as we humans can, or even are better than humans, then some stuff becomes scary. But yeah, this is another topic. We could talk about this probably for hours.
Yeah, that's the thing. But I wouldn't phrase it scary. I would really phrase it as like, well, it will probably hit a change in our habits, and well, usually people associate it with scary. Change is scary.
Change is scary, definitely, yeah.
But then whatever change it is, I hate when people say that, by the way.
That's true.
Anyway, thanks.
I would say.
Sorry?
Yeah, let's call it a day.
Yeah, let's call it a day. Thank you very much, Motzi, to teach us this very good material, and we will continue next week, I think.
Yep. And thank you to you as well, MicroD, for hosting these workshops and donating your weekends to the vvvv community, which is also I value a lot, because it's really, really cool to have all these interesting things to learn. There's many things that I missed on the last node, and it's cool to have this here.
Actually, my intention was that I wanted to learn what I missed that last node, and I figured the best way to do is organize a workshop series.
And you're performing really good. Thank you for this. Yeah, all the best to you users out there watching. Thank you for tuning in, and all the best from Vienna. And goodbye.
Thank you for watching. Have a nice day. Bye bye.